Hello, ladies and gentlemen. Today we're going to talk about trigonometry. This is a big unit for geometry, so we need to make sure that we take really good notes. Okay, we're paying attention and writing down any questions we might have. We're just going to talk about the three basic ratios today, but it is a big unit, so like I said, make sure you jot down any questions you might have right off the bat. Pause the video, take really good notes, so that way we can make sure that we understand trig before we move on. So you're going to need your foldable, something to write with, and you're definitely going to want a calculator. Today a calculator is crucial. So as we get started here is what your foldable should look like. We're going to talk individually about sine, cosine, and tangent. These are your three big trig ratios, but if you wanted to, you could cut down the dotted lines. Don't cut the paper, just cut the top flap. But again, you don't have to. It works still just the same. All right, so sine, cosine, and tangent, the three big trig hitters that we get into in geometry. Now, you've noticed on your foldable, but down the side, it says this thing that says so, ka, toa. Now, this is how we remember to set up, or how to set up our trig functions. So, ka, toa, every single triangle is different, and every single trig function is just slightly different. But now we're always going to talk about, when we talk about sine, cosine, and tangent, we're always going to have a reference angle. So a lot of times we call that reference angle theta. So it's just a zero with a belt, kind of. So every time we talk about that, every angle, the reference angle, is always going to have an opposite side, it's going to have an adjacent side, and there's always going to be a hypotenuse. So for starters, when we use trig, we're always going to have to make sure that we have a right angle. So we still need that right angle. Now, every single time, we always know that the hypotenuse is going to be that side that is across from the right angle. Now, when we are trying to determine opposite and adjacent angles, now remember, adjacent is just a fancy word for touching. So when we think about, if this is my reference angle, I'm going to change colors here just so you can see that. If I were to point out the side opposite is not going to be touching it at all. So this side would be considered my opposite, and this side right here would be considered my adjacent side. So again, every time if my angle were to change, if I were to draw this triangle one more time, if my reference angle would be up here, my opposite side would be on the bottom, my adjacent side would be on the side, and of course my hypotenuse would still be across from that 90. Now again, it's important to know this because every single time we start with these, we're always going to make sure that we talk about opposite, adjacent, and hypotenuse. So I'm going to erase all this stuff, and we're going to start from scratch. So now that we've talked about our hypotenuse, our reference angle, adjacent, opposite, hypotenuse, now we're just going to talk strictly about sine and what sine means. So when we look at this, again, we're always going to have that same reference angle. So for starters, we have this reference angle. Now, sine, so, ka, toa. The reason we memorize so is so sine, the S stands for sine, the O stands for opposite, and the H stands for hypotenuse. So what we do is we set up a ratio of opposite over hypotenuse. So when you look at this right here, again, sine would be opposite over hypotenuse, and hypotenuse again is always across from that 90. So if you wanted to write yourself just a quick note, sine is going to be opposite over hypotenuse. And this might make a little bit more sense as we move forward and have numbers involved, but we're just getting the basics down here. So then as I move to cosine, again, the C stands for cosine. The A is going to stand for adjacent, and the H is going to stand for hypotenuse. So again, we have A over H. So if I put that reference angle in there, adjacent this time, again, adjacent is just a fancy word for touching. So the side touching that, well, we have technically two sides touching, right? But one has a more important name. The one side touching it is known as my hypotenuse. So then the only other side touching this reference angle would be the bottom side. So that would be my adjacent there. So again, cosine is going to be adjacent, adjacent over hypotenuse. And again, we're just setting up my ratios here. Lastly, we have tangent. So again, we got that reference angle, but tangent, again, the T in TOA stands for tangent. The O stands for opposite, and the A stands for adjacent. So we're going to put opposite over adjacent this time. So opposite over adjacent. And again, adjacent is tough here because it looks like it's touching two sides, but remember that this side right here is my hypotenuse. So we want to make sure that we're including the adjacent side. So yes, they're both adjacent, but since this hypotenuse has a more important name, we consider the bottom one as the adjacent one. So again, tangent is going to be opposite over adjacent. So these are really, really important to remember. It's hard to remember them, so all we remember is SOHCAHTOA. All right, so as we open our notes here on the left side, we see just a couple different ratios we're going to set up here. So notice it wants us to find sine of A and sine of B. So again, I'm going to write down SOHCAHTOA, because that's what's going to help us in setting up these ratios. So now as I look at sine, so now imagine that this A was in parentheses. So now it's asking me the sine of A, so that my reference angle for starters is going to be this A. Okay, and as we think of sine then, sine again means OH, opposite hypotenuse. So I'm going to put the opposite side over the hypotenuse. So for starters, let's figure out my hypotenuse. It's across from my 90, and opposite of A would be this 6. So this would be my opposite side if we wanted to label all my sides. So opposite then, again, if we want to set this up, we're going to go 6 over hypotenuse, which is 10. Now you can leave it as 6 over 10. It doesn't matter. If you wanted to simplify it into 3 over 5, that works too. Either or. I'm just asking for the ratio right now. I would accept both. So now if I change colors here quick, my new reference angle for B here, now I want to look at B, this reference angle B. The sine, again, is still going to stay opposite. So opposite of B this time, though, is 8. So opposite of B is 8. But hypotenuse, again, yet stays the same. So my hypotenuse is always going to be the same, but as I change my reference angles, my opposite side is different. So sine would be 8 over 10. If you wanted to simplify, you could. You don't have to, but it would be 8 over 4. As I go on to cosine then, okay, again, my reference angle is going to be A, so this is the angle I'm talking about. Now I'm talking about adjacent over hypotenuse. So adjacent, again, means touching. Before I can figure out my adjacent, I got to figure out my hypotenuse. Hypotenuse always across from my 90. So the adjacent here for A looks like it's going to be 16. So again, I put 16, which is adjacent, over hypotenuse, which is 20. Again, you could simplify if you'd like. You don't have to. It would simplify down to 4/5. I'm giving you the option, completely up to you. Then for B, if I again change colors, B, here's my reference angle. Adjacent to B, it looks like is going to be 12. And again, my hypotenuse is always going to stay the same. So it looks like for B, I'm going to get 12 over 20. Again, if you'd like to simplify, you could simplify to 3 over 5. So lastly, then we have tangent. So again, tangent of A will make my reference angle A. Tangent stands for opposite over adjacent. So when we look at opposite, so opposite for sure, the only one not touching would be 15. But now I have to pick which one's my adjacent. And again, the most important one we need to figure out is hypotenuse. That one can't be my adjacent because it has a more important name as hypotenuse. So my adjacent here is going to be 20. So this time it looks like my opposite again is 15 over 20. Again, you can simplify, but you definitely don't have to. I'm going to for the sake of the video so you have the best notes possible. So lastly, let's figure out the opposite and adjacent. So opposite here is going to be 20, and adjacent again is going to be 15 because 25 has a more important name. So then this one is going to be 4 over 3. So again, if you have any questions of how I'm getting these ratios, make sure you jot those down so we can visit them when we get to class. All right, our goal then for this first example is to find BC and AC. So instead of leaving them as BC, I'm going to substitute in x's, and I'm also going to substitute in a y. We'll put them in different colors so we're solving for different things. So first thing I'm going to solve then is x. So now when I look at x, again, it's pointing out my reference angle. So this time it's giving me an actual number for my reference angle. Now I want to figure out what I have. all I'm going to do from here is I'm going to label all of my sides in accordance to this reference angle. So it looks like for sure I know that 9 is going to be my hypotenuse. X, it looks like X is the side touching, so that's going to be my adjacent side. And it looks like Y is going to be my opposite side. So all I'm doing now is labeling based on this one reference angle. So now if I'm solving for X, I can see, okay, it looks like for X, I'm going to have the adjacent and the hypotenuse. So when I think of SOHCAHTOA, I want to think, okay, which one uses A and H? SOHCAHTOA. Looks like ka, or cosine, is going to use SOHCAHTOA. So I think cosine. So cosine. Cosine is going to give me my A over H. So here's how I do this. I set up cosine, so I write cosine. Well, now every time we have cosine, we have a bubble. So in the bubble is always going to go my angle. So the angle now I'm talking about is 21. So cosine of 21, this has to equal adjacent, which adjacent here is x, over hypotenuse, which hypotenuse here is 9. So now what happens is this, I can put cosine over 1, and I have a proportion that I can cross multiply to solve. So take the extra step to write, okay, 1 times x is going to give me x. Now I get 9 cosine 21. And I want you to write this step out because now all you're going to do is plug that into your calculator, but you might plug it into your calculator wrong. So as long as you have this first step of 9 cosine 21, I can still give you full credit because we want to make sure that we're typing into our calculator right. So now all you're going to do is you're going to take your calculator, you're going to hit the 9 button, you're going to hit the button on your calculator that says COS, so cosine. It should throw up a parentheses, and you're going to throw in 21 into those parentheses. When you hit equal, you'll get back a big long decimal. So the decimal I get back in my calculator is 8.4022. I'm going to round 4 decimal places. When we use trig, we always round 4 decimal places. Okay? So again, 9 cosine 21. Type that in as best as you can. But I'm going to jump into finding y then. So again, we have this reference angle, but notice y is opposite and hypotenuse. So when I look down SOHCAHTOA, which one uses O and H? That would be SO. The S stands for sine. So we set it up the same. So sine, again, in my bubble, I always throw whatever my angle is. So 21 equals opposite would be y, and hypotenuse is 9. So again, put it over 1, and we're going to cross multiply since I have a proportion to solve. So I get y equals 9 sine 21. Again, write that step out because now we'll type it into our calculator as 9. Hit the SIN button, and then you type in 21 and close your parentheses to get y equals 3.2253. So I found y and I found x. So again, using your calculator is very, very crucial in this video. All right, so again, in our second example, let's designate AB as x, and we'll designate BC as y. So we're going to want to then first off write down, okay, we got to think SOHCAHTOA. Okay, then I figure out, okay, here's my reference angle. From there, I'm going to label every single side I have. So with this reference angle, notice the easiest one to label is the hypotenuse because that one is always, always, always across from my 90. X looks like it's my opposite side. And y then leaves that to be my adjacent side. And again, adjacent just means touching. So the first thing I'm going to solve for is x. Now when I look at x, it looks like x deals with opposite and hypotenuse. So when I think about opposite and hypotenuse, when I look down SOHCAHTOA, opposite and hypotenuse deals with SO. SO stands for sine, so I'm going to write sine. Again, in my bubble, we always have a bubble. My reference angle this time is 37 equals O, again, SOHCAHTOA is O over H, so opposite, which was X in this example, over H, hypotenuse, which is 13. Again, let's put sine over 1. We're going to cross multiply. I get X equals 13 sine 37. Again, write that step out, so in case you type it into your calculator, you can still get full credit. So if I type 13, sine button, 37 equals, this time I'm going to get 7.823. Looks like I'm going to have to round that 5 up to a 6. And that's what I get for x here. So let's jump down to y then. So again, when I'm talking about y, this time it looks like I'm dealing with adjacent and hypotenuse. Y is dealing with adjacent and hypotenuse. So if we look there, we can deal, and again, I know I'm dealing the hypotenuse here because that's the only known I have. This x I could use, but then I'd be using a decimal and I don't want to do that. So I want to use these two because I have those two. So adjacent and hypotenuse, that looks like I'm going to use ka, which again, ka is cosine. So let's start by writing cosine. In my bubble, I always put my reference angle, and in this example, it's 37, equals a over h. So a comes first, so that means I'm going to put y on top, over hypotenuse, which is 13. Again, we'll put cosine over 1, cross multiply, I get y equals 13 cosine 37. So when I type that into my calculator, it looks like I'm going to get back 10.3823. So now I have solved for both AB and BC. Again, jot down any questions you might have so that we can address them in class. All right, our last example of the day. Again, let's label AC and AB. We'll do AC as X and AC as Y. Notice this time, though, my unknown is that hypotenuse. So this is going to change things up just a little bit. We'll get jotted down the SOHCAHTOA. And then I'm going to circle my reference angle and I'm going to label my triangle. So it looks like X is going to be my opposite side. Y has to be my hypotenuse because it's across from my 90, leaving 20 as my adjacent, the only side touching that's not my hypotenuse. So then I'm going to set up problems. So again, if we want to solve for X first, we want to use two things that I know. So I don't want to use X and Y because those are two unknowns. So I want to do X, which would be opposite, and the only other unknown would be 20. So I have opposite and adjacent. So this leaves me to use the O and the A, which is going to have me use tangent. So I'm going to do tan. Again, inside my bubble always goes my reference angle, and in this example it's 50, equals opposite over adjacent. So opposite here is X over adjacent, which is 20. Again, put tangent over 1, cross multiply to solve. Looks like I get X equals 20 tan 50. X is going to equal, when you type that in, again, you'll hit the 20 button, or hit 20, hit the tan button, and then you type in 50. You should get back 23.835. That 0 turns into a 1. And that's for X. Now when we solve for Y, okay, let's look at Y. So Y, the only other unknown, I don't want two unknowns, so I'm going to use 20 again. So it looks like I'm using hypotenuse and adjacent. So hypotenuse and adjacent, A and H would be ka, which is cosine. So I'm going to start by writing cosine. Now my reference angle again inside the bubble goes 50 equals A over H. This time I'm going to have to put 20 over Y. Now notice this is the first time we've had Y in the bottom, but again we're still going to put the cosine over 1 and cross multiply. So I'm going to get 20 equals Y cosine of 50. So notice now I got to get y alone. Y's not already alone, so I'm going to have to get rid of this multiplication of cosine. And I know it's multiplication because there's nothing else between the y and the cosine. So I'm going to have to divide both sides by cosine 50. So it's going to be 20 divided by cosine 50. So in your calculator, you're going to want to type y equals 20 divided by cosine 50. So when you type that in, the decimal you get back, 20 divided by cosine of 50, the decimal you get back is 31.114. The second 4 turns into a 5. It gets rounded up. So your y value is 31.1145. So some of you might have been typing in your calculator along the way. If you would have gotten a different answer, your calculator might be in a different mode, and that's something we can absolutely fix. But remind me when you get to class. So I want to make sure that if you have any questions, you jot those down So that way when we get to the worksheet, it's kind of smooth sailing. Again, it's going to take a little while for you to get in the habit of things, but please, please, please bear with me because this is so, so important, and I promise you it'll get easier the more you practice. Practice makes perfect. Practice, PMP, practice makes perfect. PMP. So remember PMP, okay? So thank you for bearing with me through this longer video. I know it's a long video, but I promise you it'll pay off if you actually listen to your video. So thank you, thank you, thank you. If you're still listening to me, why don't you send me an email right after you watch this video? Send me an email with your favorite candy. And if you tell anybody else, if I get an email from all students, I'm going to know that you didn't watch or you spread the word. And if everybody gives me their favorite candy, I can't give you that extra bonus point. Okay, so thank you for listening all the way through the end. Send me an email with your favorite candy and I'll give you a bonus point. Thank you. Kessler out.